Example 4, find probabilities of independent events. Alex has 2 yellow shirts, 1 blue shirt, and 1 green shirt. She cannot decide which to wear today, so she chooses one at random. The probability of rain today is 40% or 2 out of 5. What is the probability that Alex chooses a yellow shirt and it does not rain today? Got a few things we have to look at here. So probability that Alex chooses a yellow shirt and it does not rain today. Okay, so let's call not rain probability not rain. The probability it will rain is 40%, 2/5. So that means I'm going to have, again, I'm going to use this as the complement, 1 minus the probability that it will rain. We'll say that this is the probability it will rain. That equals 1 minus 2/5, which is 3/5. And now let's check out the probability of choosing a yellow shirt. So the probability of a yellow shirt. Okay, so let's see, yellow shirts. She has 2 yellow shirts, so 2 out of how many? 2, 3, 4. She's got a total of 4 shirts. And I can reduce that down to 1/2. So now I have an and statement. I also have 2 independent events. So I'm going to have the probability of yellow shirt and no rain is going to equal the probability of that yellow shirt times the probability of no rain, which is 1/2 times 3/5, gets me 3/10, which is also 0.3, which is also 30%. What is the probability that Alex chooses a yellow shirt and it does not rain today, or that Alex chooses a green shirt and it rains today? Wowza, this is a big one. Okay, so we have a lot going on here. So we have probability chooses a yellow shirt and it does not rain today. That is what we just calculated. And then we have this other one. Alex chooses a green shirt and it does rain today. Also, let's pay close attention to that word or between those 2 statements. So this is going to be mutually exclusive. There's no outcomes that are in both events. So let's do this as, we'll call green shirt G, rains today is R. So the probability of G, green shirt, and it rains today. Okay, so these are independent events. So that is the probability of green shirt times the probability of rain. The probability of a green shirt, let's see, what do we got here? Green shirt, green shirt. 1 green shirt. There's only 1 green shirt, so that's 1 out of 4. And the probability that it will rain, we were given that was 2/5. So we get 2 over 20, which reduces down to 1 over 10, which is also 10%. So now let's apply that or statement. So my first one, we're going to have, I'm going to use brackets so I'm not going crazy with parentheses. Probability of yellow shirt and no rain, or that's where this or is coming from right here, or we have the probability of the green, oops, I need a parenthesis, green and rain. So that is going to be the same as the probability of yellow and no rain, because it is an or statement and it is mutually exclusive, plus the probability of green shirt and rain. So we calculated this one, and we're just going to use the percents. So the probability of a yellow shirt and no rain, let's use the percentages, was 30%. And the probability of the green shirt and the rain was 10%, which gives us a total probability of 40%. And let's take a look at the try it. You spin the spinner 2 times. Assume that the probability of each of blue, each spin is 1/3, and the probability of orange, each spin is 2/3. What is the probability of getting the same color both times? Explain. So when we are spinning a spinner, those events are going to be mutually exclusive. So let's make a note. This is mutually exclusive. So, and each time I spin that spinner, it's an independent event. It is with replacement, essentially. So that means if I want to spin, you see the probability of spinning the blue twice. Probability of blue and blue. Because those are independent, I'm going to take the probability and I'm going to multiply them together. And the probability of spinning blue was 1/3, 1/3. 1/3 times 1/3. So we have a 1 in 9 probability. Now let's do probability of spinning orange both times. So probability of O and O. And again, these are independent events, so I'm going to multiply them. And that probability was 2/3. And so I get 4/9. So now what is the probability of getting the same color both times? So then the probability of the match is the probability of blue and blue plus the probability of orange and orange. Probability of blue and blue was 1/9. Probability of orange and orange was 4/9. So there is a probability of 5/9.